Thank you to Kodak for approving this video and providing the information needed to make it possible. Camera film is made up of layers. The emulsion layers are responsible for capturing the image. These are made up of silver halide crystals suspended in gelatine. Silver halide is sensitive to light, which is how images are formed. During the manufacturing stage, different size crystals are used to create a variety of film sensitivities. Larger crystals have more surface area to capture light than smaller crystals. Therefore, by adjusting the sizes of the crystals, you adjust the exposure index. The higher the exposure index, the larger the crystals are. However, the larger the crystals are, the more visible the grain is. This is why faster stock appears to have grainier footage. The exposure index of film can also be referred to as the film's speed. The faster the stock, the higher the exposure index, and the slower the stock, the lower the exposure index. Emulsion layers are made of 2 or 3 layers themselves, each with different film speeds to capture all levels of light and give the film more latitude. Please note that these film layers are not to scale, and a more accurate design would look like this. But for the purposes of this video, we'll be using this structure. Film responds to light and colour in a similar way to that of a human eye. Each of these layers of emulsion is responsible for capturing one of the 3 primary colours: blue, green, or red. This is inspired by how the cones in our eyes perceive colour, each responding to one of these 3 wavelengths. Similarly, when film is exposed to light, the silver halide crystals will respond to the wavelengths according to which layer they're in. However, it's important to know that these crystals have an innate sensitivity to blue and ultraviolet light. Because of this, the blue sensitive layer is placed at the top. Next, there is the green and red sensitive layers. But as we established before, silver halide is always naturally sensitive to blue. So any remaining blue light that was not absorbed by the blue layer must be removed. This is achieved with an extra yellow filter, placed directly below the blue sensitive layer. Since yellow light is made from green and red light, these waveforms are allowed to pass through, but the blue waves of light are absorbed. There are also dyes which coat the silver halide crystals on each layer and enables them to only absorb the correct wavelengths. These are called sensitizing dyes, and as we established before, yellow absorbs blue, so the sensitizing filter dye on the blue sensitive layer will be yellow. The same logic is applied to the green and red layers, which are also coated in their inverted colours. So as you can see on this colour wheel, there are magenta dyes on the green sensitive layer and cyan dyes on the red sensitive layer. In the same way as the blue sensitive layer, where green waves of light reach the silver halide crystals in the green sensitive layer, green is absorbed and a reaction occurs. And where red waves of light reach the silver halide crystals in the red sensitive layer, red is absorbed and a reaction also occurs. There is also an additional interlayer between the green and red sensitive emulsion. This is a magenta filter layer, used to absorb any remaining green light that passes through from the green sensitive layer above. Since green is the opposite of magenta, the green light is absorbed by this filter, whereas the red light is allowed to pass through. This layer, alongside the yellow filter layer, also offers some separation for the emulsion layers, and during the processing stage, prevents unwanted reactions migrating across the colour-sensitive layers. There are also a number of other important layers, each with their own purpose, like the supercoat. This is made of gelatine and protects the film from scratches. Next is the ultraviolet layer. This absorbs UV rays so that the blue layer will not be exposed by them. This layer also contains a material called Lippmann emulsion, which, during development, acts as a barrier to protect the film from unwanted chemistry in the processing tanks. The subbing layer acts like a glue so that the emulsion layers adhere to the film base. Up until the 1950s, the film base was made from cellulose nitrate, but this proved to be unsafe to store since it was far too flammable and would combust as it deteriorated. So a different celluloid-based material was developed that was much safer to use, called cellulose triacetate. For Kodak camera film, cellulose triacetate is still the selected choice because of its ability to break rather than break the camera. However, since the 1990s, many other motion picture lab films have converted to a polyester film base due to its stronger structure, longer shelf life, and minimal deterioration. There is also the REM jet layer, made from carbon black material. During exposure, this backing prevents light bouncing off the back surface of the film strip, as well as from the pressure plate in the camera. Without this backing layer, the film could be re-exposed, leading to halos around bright objects. This is an effect called halation, which is why the REM jet layer is also referred to as the anti-halation layer. After the film is exposed in the camera, the image is still not visible. Exposing the stock creates a latent image, which becomes fully formed during development. For colour film, it also still doesn't have any colour. It's just the information needed to create colour that has been captured. This is all completed when the film is processed. Film processing is done using different chemicals in different tanks, all in a specific order with precise times and temperatures. The first stage of processing is the pre-bath. The pre-bath is used to wet the emulsion, to start its swell, and also to soften the REM jet backing so that it can be removed in the next stage, called the REM jet removal stage. For colour film, the next stage of processing is called coupler development. The emulsion is dipped in a chemical developer so that actual black silver is formed where the silver halide crystals have absorbed light. Amongst the crystals there are tiny particles that are used to form dye, also known as imaging couplers. Each layer is dyed in inverted colours, so the blue sensitive layer would be yellow, the green sensitive layer would be magenta, and the red sensitive layer would be cyan. For colour negative film, when black silver is formed, the colour developer itself is oxidised, and this then reacts simultaneously with the imaging couplers to form dye alongside the black silver. Therefore, an inverted photographic image is created. Also for negative emulsion, there are additional dye particles present in the green and red sensitive layers. These are known as colour correction masking couplers. The green sensitive layer has yellow masking couplers, and the red sensitive layer has magenta masking couplers. These are in the film from manufacturing and stay in the film through processing, unless they are near the exposed silver halide, in which case, similarly to the imaging couplers, they react with the oxidized developer and change colour. So, in the red sensitive layer, the magenta masking couplers would become cyan. On a molecular level, what happens is that when the original masking coupler reacts with the oxidized developer, the cyan structure is formed and the magenta structure is detached, making it soluble and able to wash away, leaving behind the cyan structure, which is now permanent imaging dye. This is the same with the green sensitive layer, where the masking couplers are originally yellow, but leave behind magenta imaging dye if they react with the oxidized developer. However, the masking couplers near the unexposed silver halide don't change at all and remain as their original yellow and magenta masking coupler structures. The combination of these cause an orange mask to cover the film, since magenta and yellow together create orange. Therefore, where the exposure or density of the film goes up, the masking effect goes down. These masking couplers help to correct brightness and saturation errors when the film is printed or scanned. They are also known as process surviving and stay permanently on the film. However, sensitizing filter dyes and both the yellow and magenta filter layers are not process surviving and are removed in this stage since they were only needed when the film was being exposed. After this, the stop bath is used to stop the chemical process of the developer, and then the film is bleached. Since colour film is formed with dye, the silver is no longer needed, so bleach is used to convert the black silver back into silver halide. This is then washed away by the fixer, along with the unexposed silver halide and unused imaging couplers. A wash then removes the fixer chemicals, and then lastly, the film is washed with water and dried. Colour reversal film, however, doesn't have masking couplers, as colour correction isn't as necessary. Dyes are also formed differently with reversal film, and the coupler development stage is broken up into two parts rather than all in one. For the first part, the developer turns the silver halide that has absorbed light into black silver. This process is then stopped with the stop bath. For the second part, colour developer is used to reduce the remaining silver halide to black silver. This reaction then oxidizes the developer and causes the imaging couplers to form dyes, alongside the black silver formed in the second reaction. This is different to negative emulsion, because instead of forming next to the silver halide that has absorbed light, the dye forms where the silver halide has not absorbed light, therefore creating accurate colour representation. For example, if the subject was green, there would be a reaction on the green sensitive layer, but in this case dye would only form on the blue and red layers, creating yellow and cyan, and the combination of yellow and cyan together creates green. This is the same when representing all other colours as well. This process is then stopped again by the stop bath, where the yellow and magenta filter layers and sensitizing filter dyes are removed and washed away. At this point, similarly to colour negative film, bleach turns the black silver back into silver halide so that it can be washed away in the next stage by the fixer. After this, the emulsion is washed and finally dried. Once these stages are complete, the emulsion is no longer sensitive to light and doesn't need to be kept in the dark, as the images are permanently captured on the film strip. Thank you for watching, and don't forget to subscribe for more.